Hello. This presentation is about text mining and how we try to develop a better product into official statistics. And the main point here is how to deal with subpopulations. It deals with the case of cybercrime. Statistics Netherlands has received police registration data of 2016, and these are data on incidents in society. Victims of an incident or of a crime can go to the police station and tell them the story, what happened to them. And this story is then entered into the police registration. And the police also adds a code to each incident, and this concerns a code for crime type. The police themselves also can enter an incident in this registration, for instance, when there's a burglary or where there's a traffic incident. And they also will report certain text in the registration data. Recently, the police is interested to estimate the number of cybercrime in society, and they have asked Statistics Netherlands whether it would be possible to use text mining to predict cyber-related crimes. And with cyber-related crimes, they mean two groups. You have pure cyber, like hacking and DDoS attacks and so on. And you have IT-related crimes, for instance, online identity fraud, purchase fraud, and so on. We have established two labeled sets to train a text mining model. We have a selective set, which is based on keywords. With the keywords we have selected for the term cybercrime. And we also have a random set where we sampled random from the population. CBS last year developed a beta product. It's based on a support vector machine. It uses bag of words as the features. And it predicted about 9% cyber in the Netherlands in 2016. And the model has a high precision and a bit lower recall for the phenomenon of cybercrime. They published a table, which is shown in the upper right with the beta product. And you see here that swindle has a lot of cybercrime, and violence crimes also had a small proportion of cyber-related aspects. Now, in total, there are about 30 crime types. And the question is, can we really publish reliably the percentage of cyber by crime type, so by subpopulation, and how can you analyze this? Now, first of all, we discovered there's an issue of missingness. So not all of the records in this register have a text field. And okay, if we do not correct for this, this may lead to a bias. So we looked further into this and we discovered that the amount of missingness varied greatly by crime type. We looked further into this and we used a logistic regression and on a number of background variables that can be found in the register. And we found that the missingness was related to crime type, whether the incident is declared by the victim or by the police, and whether it concerns a main crime or not. Given the selectiveness, we were interested whether we could correct for it by imputing cybercrime. And within the labeled set, we tried to model the relation between cybercrime and the background variables. And we found that cybercrime was related to crime type, to whether the crime was declared by the victim or by the police, and whether it concerned a clarified incident or not. And this model fitted the data rather well. So we think that as long as the number of missingness is not too high, we can impute cybercrime for those records. Now, how did we analyze the effect of the subpopulations? We had two blocks. We had the analysis approach and we had the retraining. So I start with the analysis approach. And we had 4 layers. We looked at the accuracy of the output, so the percentage of estimated cyber. We looked at the model performance at a global level. So what about F1 scores, precision and recall, these kind of things. In the 3rd layer, we look at the performance of the model at the subpopulation, so at the different crime types. And the 4th level was the local model performance, and we mean the performance of the model for individual predictions. Now, due to the time restrictions, I will not show the results of the 4th layer. The retraining, what we did, we run a test on significance of subpopulation effects. I'll explain it in a minute. And based on the results of this test, we retrained the model, we made new predictions, and the results of those retraining were analyzed. Then we go to the retraining. We used the G-square test for a log linear model. And we were interested whether the association between the true labels and the predicted labels were affected by crime type or not. And we also looked in, slightly deeper, and we said, given the label, are the errors that are made by the model affected by crime type or not? So for label 1, crime type, and label 0, label 1, cybercrime, and label 0, no cybercrime, we tested it separately. And we combined then all of the crime types that were significantly affected. We had a number of training settings. We had the basic model, which then concerns a single model. We had a binary model in which all significantly affected crime types were trained as one group and non-significant ones as the other group. We had deviation, in which each significantly affected crime type a model was trained separately for, and then all the others. And the setting all means that all of the crime types a model was trained separately on. And for binary and deviation, we had 2 variations. And the variation concerns the crime types that were considered to be significantly different. It was either based on the complete association or on the effect per label. Concerning the data, and the model, we first set the tuning parameters using a cross-validation procedure on a small set. We had 2 labeled sets, as I told in the beginning, a random and a selective set. The random set we used to estimate the output accuracy, because it was an unbiased sample. And the complete data set, so random and selective, is used for the tests of the subpopulation effects. So although the accuracies of the set cannot directly be used, we believe still that it can be used to see whether there are subpopulation effects. And in both cases, we used weights, and those weights are used to make the sample as representative as possible for the full population. And these weights are not used in the training, but the weights are used when then we look at the performance of the model. So the first thing we look at is the output accuracy of the estimated percentage of cyber. And we found that the variance of this estimator is very small, which is because we have nearly 900,000 records. So we can forget about the variance. It's all about the bias. And we found in our situation a case study that the true percentage of cyber was underestimated by the model. In the basic model here, you find it's 1.5% underestimated. And when we had these retrainings, all these colored bars, you see that the bias changes. And well, it's relatively rather sensitive. And the reason for this is that when you have a low base rate, then the bias is sensitive to small changes in the accuracy of the model. Well, concerning the global model performance, we looked at a number of measures. First of all, we have the precision and the recall of the no cyber class. And we found this one was much better than the recall and precision of the high cyber class. The G-squared test resulted in a rather large value. And the consequence of this is there were a number of crime type classes that were significantly affected. So the association, the model accuracy varied for those crime types. And the number of those crime types that, of the 30, 4 to 6 of those crime types were significantly affected. And the most important conclusion was that retraining didn't reduce this number of significantly different crime types. We found that the macro values were F1 values were lower than the micro F1 values. The reason is that the accuracy or the performance of the cyber class was poorer than of the no cyber class. Furthermore, the recall, overall the macro recall is better than the precision. And finally, we looked at entropy R-squared, which means that you look at the probability mass of the predicted labels. So what is the probability when the true label is label 1? What is the probability of predicting label 1? And if the label is 0, so no cyber, what is the probability of predicting that label? And we found that there was a slight improvement with retraining of the model on the entropy R-squared, but it was only a little bit. The third layer and the last layer that we will discuss is the subpopulation model performance. This one here, the top row, is the basic model. I have 4 crime types as an example here. And for swindle and forgery, you see there's a lot of mass here. So the units are predicted to cybercrime and they are labeled as cybercrime. It's nice. But we also have a group here and they are predicted as cybercrime, but in fact, it concerns no cyber. Whereas with arson and abuse, this group is missing here. But you see here a group, so it's predicted as no cyber and affected is cyber. It also occurs here. After retraining, the setting all means you retrain on each crime type separately, can have separate model parameters. And unfortunately, the problem is not disappeared. I mean, you wanted to have all the units on the diagonal and it doesn't happen. To conclude, the main point of this presentation is that you cannot just tabulate machine learning outcomes by subpopulations if you didn't train for this in the first place and if you didn't test whether that can be done. And to analyze whether it can be done, we propose to look at 4 levels, to look at the output accuracy, to look at the global model performance, to look at the performance at subpopulation level, and to look at predictions at individual records. But I haven't shown this latter point. Concerning our specific case study, unfortunately, retraining by crime type, it was not successful. It solved the bias problem, and it definitely didn't solve the problem that the accuracy of the model still varies by subpopulation. What we like to do in the near future is to retrain not on crime type, but to retrain on cyber type. So say, look, we have pure cyber, and we have these IT-related aspects, like online identity fraud and purchase fraud. And maybe these are really, we looked into the data and it appears to be that they're really different kind of things with different words that are predictive for those 2 different cyber types. And there's also a mixture of those cyber types within the crime types. So we have good hope that when we retrain on those cyber types, that also the effect of crime type is solved. Furthermore, we still have a very simple model and we could improve on the features, and I'm sure there are other kinds of improvements possible. Thank you so much for your attention.